Hey everyone, welcome to Intellipaat's YouTube channel. In today's session, we will be learning about Azure CosmosDB.
So before moving on with the session, please subscribe to our channel.
And also hit the bell icon for the upcoming updates from our channel. And also, if you enjoy our content, you can leave a like.
The agenda for today is, first of all, we'll see what a database is and what are the different types of databases. Then we'll explain what Azure CosmosDB is, what are the key features of Azure CosmosDB and how Azure CosmosDB works. We'll also see what are the backup and restore options that Azure CosmosDB has. Finally, we'll also see the common use cases and a hands-on session on how to create a Cosmos database. So let's get started. First of all, what is a database? In simple words, a database is a collection of data that is organized so that it can be easily retrieved and managed. A very simple example of a database is a register that we used to have in our classes where our roll numbers and names were listed and the attendance was marked. So that is a database. It contains information about us and whether we were present on a certain day or not. So that is a simple example of a database. But the database that we are talking about today is are the ones that are stored in computers so that associated applications can access, manage and retrieve data from them. So these databases are not very simple like the ones in our registers, but these are very complex and these are very these store data that come in very huge volume sources. So that is what a database. So now let's see what are the different types of databases. Talking about the different types of databases, there are actually a lot of different types of databases. But since this video is focused on Azure CosmosDB, we need to know what is a relational database, what is a NoSql database, a distributed and multimodal database. So first of all, we'll see what a relational database is. So in our previous example, we were talking about the register in which data is stored. So our attendance was marked and all. So that is a table actually. So if you see in the table, each roll number, if the starting column is a roll number, each roll number is a person, and the columns, all those columns are information about this person. So the data is related to each other. Such databases are called as relational databases. And so all these data are stored in tables, and this table can be related to other tables also. If, for example, we take the example of a table that contains the names of different music present in albums. So there can be a column called genre. So like there can be different table where all these artists are names of artists are present and the genre in which these artists make music. So these tables can be related with using this keys which are unique identifiers of each of them. So different tables can also be related. So such databases are known as relational databases. Now the next one is NoSql database. So earlier we were talking about relational database, and we commonly use query language known as SQL, which is structured query language, to access, retrieve, edit, manage all the relational databases. So the databases that are different from tables, like databases that store data in the form of documents, key value pairs, or graphs, etc., are known as NoSQL databases. Then coming to distributed databases is when rather than storing the data in a single place, if the database is stored in multiple places, then it is known as a distributed database. And now finally, what is a multimodal database? Multimodal database is one that supports both SQL as well as NoSQL databases. It can support both tables, documents, key value pairs, graphs, objects, etc. So that is a multimodal database. So moving on. Conventionally, the databases that we are familiar with are relational databases. Like NoSQL databases is the other one that we are going to learn about because CosmosDB is a NoSQL database. So we have to see the difference between these two. First of all, as we have already discussed, in relational database, data is stored in tables, but in NoSQL database, data can be stored as documents, graphs, key value pairs, etc. Then the next one is scalability. So what is scalability? So when we are creating a database, and sometimes in the future, if the database becomes bigger, we need to expand it. So the ability of a database to expand is known as scalability. So when we are expanding the database, it can be either by adding more resources to the server that the database is stored, or it can be like adding more servers. So if you are adding more resources to this one particular server, then we are calling it as vertically scalable. If you are adding more servers or adding more hardware, then it is known as horizontally scalable. So a relational database is vertically scalable and a NoSQL database is horizontally scalable. Also, in the next one is in a relational database, there is a predefined schema. There is a particular way in which data has to be stored. But in NoSQL database, there is no such thing. So, and hence it is much easier to update. The next thing is a relational database supports a very powerful query language. We have talked about SQL, but in NoSQL database, the query language is not as much powerful. It's simple. Then in relational databases cannot handle huge volumes of data. It can handle small to moderate, but NoSQL databases can handle very high volumes of data. Also, relational databases has a very centralized structure, but NoSQL is decentralized. And relational databases, data cannot be written from like many locations. It can be written either from one or a few locations. But in NoSQL databases, data can be written from any number of locations. So that covers up the differences between relational and NoSQL database. So let's get into what we came here for today. So what is Azure CosmosDB? So Cosmos database is a globally distributed, low latency, multimodal database for managing data at large scales. It is a cloud-based NoSQL database offered as a platform as a service from Microsoft Azure. It is highly available, it has high throughput, and it is very reliable, and is often called as a serverless database. So as we have discussed, Cosmos DB is nothing but a database which can support data in huge volumes. It is multimodal. It can support different kinds of data, and it is globally distributed. Now we'll see what are the features of Cosmos DB. So first of all, globally distributed. As we already said, Azure has multiple regions known as Azure regions where servers are spread out, and since Azure has such a large network, the data can be distributed anywhere. So that's why it is called globally distributed. Then the next one is scalability. As we've already said, we have defined scalability. Now, Cosmos DB is horizontally scalable, and this means that it can support hundreds of millions of reads and writes per second. When the need comes, it can be upgraded. That is what this means. Then indexing. Azure Cosmos has automatic indexing, schema agnostic indexing, which means that we don't need to worry about what the schema is and all. If we are providing data, it can automatically index the data. Then Azure Cosmos DB is multi-modal. It can store data in key value pairs, document trees, graph trees, anything. Then it is highly available. In most of the cases, when you are retrieving data from the database or an application is doing that, Azure Cosmos DB is available 99.9% of the time. It is highly available. Then low latency. As I've already said, the Cosmos DB is a globally distributed database, and this means that data can be stored very close to the users. So this means when the user is retrieving data, the latency will be very less. Now we'll move to how does Azure Cosmos DB work. So as I've already said, Cosmos DB has a multi-master support, which means that can be simultaneously written to different databases spread out globally. So in this way, data is replicated to the user's region so that it can be accessed faster. But what happens is that when this data is stored, usually this data is stored in the primary node and it is replicated to the secondary nodes. So if the primary node, for example, if it's a website and the user, the data is written in a server in US, and the users are from all over the world. So if a user is from US and he's accessing the data, he'll get it much faster than the people in around the world. So this is what there is a term called consistency which defines this. So we'll see what consistency is. So consistency indicates whether data are in sync and are at the same state at any given point in time. So that's what consistency is. So Cosmos DB offers multiple levels of consistency with varying performances and availability. Now we'll see what are the consistency levels offered. First of all, there is eventual consistency. Here, the data is written on the primary node and is propagated eventually to read-only secondary nodes. It might take some time for the users to get updated data, but this is very powerful as in it offers good performance because here, if we go to the previous example, if the data is being written in the US and people are accessing from, for example, India, they'll get the performance, they'll get the data much faster, but they'll get updated only after some time due to the network latency issues. Then we'll have strong consistency. Here, what happens is
Just a quick info, guys. Intellipaat provides Microsoft Azure certification training, mentored by industry experts. the course link of which is given in the description below. Now, let's continue with the session.
The data won't be available for the user unless it is updated everywhere, including the primary node. So, if I have committed some new data into the database and a user is accessing it from, if I committed it to the primary node in US and a user is accessing it from India, he will not get the updated data unless the data has been updated everywhere. Even if the user is accessing it from the primary node, he will also not get the updated data unless the data is updated everywhere. So this is what is called a strong consistency. But the problem here is that for low performance, because the people are not getting the updated data as quickly as it is in the eventual consistency or eventual consistency, because it will take some time for the data to get updated everywhere, and only then the people will be getting this data. So this offers low consistency. So between this eventual consistency and the strong consistency, there are three different other consistency levels also which are offered. So they are consistent prefix. In consistent prefix, the client can read data in the same order as it is written. For example, if someone is committing data in the order as first A is committed, then B is committed, C is committed, and D is committed, a user reading it will also get the data in the same order, as he will get the first A, then B, C, and D. So that is what consistent prefix is. In session, users who have committed the data will be able to see it, but for the other people, it will take some time for the data to get replicated to their location. So that is what session is. Then bounded staleness. In bounded staleness, here we can set the staleness period for which the data won't be replicated to the secondary node. So if I set the bounded staleness to 2 hours, so once I commit the data, it won't be available to anyone for 2 hours. It will only be available after 2 hours, so that the data is updated everywhere. I can set the staleness to period to anything that I want. If I set the staleness period to 0, it becomes a strong consistency. So now we'll see how data is provisioned in Azure Cosmos database, or what provisions does Cosmos database provide for storing data. So there are three. First one is Cosmos database itself, then the containers, and then items. So Cosmos database, as we already said, is a database, and it has a rich API support, and because of which we can access and manage the data using SQL API, Cassandra API, Azure CosmosDB API, and also MongoDB, etc. So these can be used to enumerate, read, create, and update the database. Then there are containers. These are horizontally partitioned and replicated across multiple regions for scalability and throughput. So these containers are actually groups of all these databases and actions, and they can also be created, updated using the CosmosDB API. Then Cosmos items. Items are just the data that is committed into all these databases. It can be rows in a table, documents, graphs, etc. These can also be edited, updated, replaced, read, etc. using the APIs. Now we'll see what are the backup and restore options that CosmosDB offers. So there are two kinds of backup. First one is the periodic backup mode. In the periodic backup mode, the backups are taken periodically, and we can set the time interval and the retention interval. So we can say if we want the backups to be taken every day or something like that, we can set how much time should lapse between two consequent backups. We can set that basically, and also the retention interval. So for how long the backed up data is stored, we can also set that. The backup data is stored in different servers so that it doesn't get destroyed when something happens to ours. So that happens like that. And also in the continuous backup mode, the data is backed up continuously and can be restored to any point in time within the last 30 days. So it actually backs up the backup of the system is taken at every point of time, so that I can change I can undo any small issue that has taken place. I can undo that for the last 30 days. So that's the backup and restore options. Now coming to the common use cases. The first one is IoT. As you all know, IoT deals with huge volumes of data, and this data is coming from different locations all over the world. So this data needs to be written, analyzed, and retrieved quickly. And CosmosDB can be leveraged here because, as we already discussed, CosmosDB can do all this. In the next one is retail and marketing. Here also CosmosDB can make smooth addition, updation, and retrieval of huge volumes of data related to product catalogs, logistics, inventory, etc. Then in gaming, So recently, since all of the world are connected, and like internet has become this huge thing, people are always gaming. And see, so a lot of data, as in game statistics, are coming, and so Azure Cosmos DB can actually provide help in giving low latency game stats, scoreboards, social media integration, etc. Also in web and mobile applications, it can be used in web and mobile applications for modeling social interactions, integrating with third-party services, for building rich personalized experiences, etc. Okay, so we have discussed most of the theory regarding Azure Cosmos DB. Now we'll see how a Cosmos database can be created. So first of all, we need to have an Azure account to log into the Azure portal. This is how the portal looks like. So for creating a Azure Cosmos database, first of all, you have to click on create a resource. So here we can see the list of resources that Azure allows us to create. So we need to create a Cosmos database. So we'll click on Cosmos database. So as we already mentioned in the theory part, Azure Cosmos DB has multi-API support. That means you can use SQL API, MongoDB, Cassandra API, Gremlin graphs, etc. to query the data that is stored in the database. So for the demo purpose, we will be selecting SQL API. So we can click on create, and then we have to give the basic information about the database. So first of all, we have to select the subscription type. I have selected it as pay as you go. We have to select the resource group, or else if we don't have one, we can create a new resource group, the resource user group, which this database will be belong to, and then we can give an account name. This is the name by which the database will be identified. We can give the location. We can provide the capacity. Then going to the distribution tab, we have already mentioned that Azure Cosmos DB is globally distributed, so we can have global geo redundancy enabled. Then the networking is just self-explanatory. It's a kind of network that Azure will be accessing the database from. Backup policy, here we can select the kind of backup that we need, whether it's periodic, whether it's continuous. If it's periodic, then interval at which the backup have to be taken, the retention period, etc. Then encryption and tags, you don't have to worry about that. And then finally, you can review and create. If you create an account, it will take some time for the database to be created, because it has to happen on a global scale. So it will take around 15 to 20 minutes. So for the sake of time, I've already created a database. I have given the name of the database as Cosmos DB SQL123. I've just given a random name. So if I click on the database, I can see the overview of it, the status of it, that is it is online. The resource group it belongs to, this is a resource group that I've created, RESC1, the type of subscription, the read and write locations, the URL. So the name that I gave will be how the database will be identified. So Cosmos DB SQL123 was the name that I gave. So that comes in the URL. Then the backup policy. So we have actually now created a Cosmos DB account. Now we have to create a database in which data can be added. So for that, we have to first go into the Data Explorer. So in the Data Explorer, we have to create a container. So we have to click on New Container, and then we have to give the details of the database. So first of all, we need to give a database ID. So I'll be just giving it DB1001, and then we have to give the container ID, that is, I'm just giving it a CONT1001, and then we have to give the partition key. I am just giving it as category, and then I can click on OK. Now it will take some time for Cosmos DB to create this container. We can see the loading buttons going on over here. So as you already mentioned in the theory, the data is provisioned in Azure Cosmos DB in the form of containers, databases, containers, and items. Databases forms the bigger part, containers come inside them, and in the containers, then we'll be having items. So our container has been created. So if we go, we can see that the name of the database that we have given, DB1001, is here. If you click on it, we can see the container that we have created, container 1001. If you click on that, we can see the items. So items are the data that we enter into this database. So if we click on items, we can have this button new item. So if I click on new item, I can give new items to the database. So this is just a JSON file. So I can keep the ID for the item, for example 1001, and if we click on save, it gets saved. So a new entry has been made into the database. Similarly, I can create new item with a different ID. So if I go and give 1002, I can see, and if I go and save, I can see that it has been added to the database. So this is how you add different entries in the database. And at the top of the table, you can see there is select from C. So this is querying. You can use this to query and access different data from the database. So that is how you create a database and query the data from the database in CosmosDB. Now we'll see about the different features that we talked about in the theory session. So first of all, if we go into replicate data globally, here we have already mentioned that CosmosDB is a globally distributed database. So here we can see we can select multiple read and write regions for the database. Here it has already been selected as West US and East US. But for our purpose, if we need the data to be closer to India, we can choose a region near India to store our data. So it is for our convenience. We can choose the regions to which the data should be written or read from. So in the case if the primary read location or the primary write location fails, the CosmosDB has a feature where it will automatically switch to a secondary read location and make it as the primary write location. So that is what manual failover is. If you go and click on manual failover, if you have multiple read locations, you can set a priority order for the read locations in such a way that if the write location fails, it will automatically switch to the first priority read location and make it the write location, so that our database will keep on functioning. Then we can see the consistency options. We have already seen the consistency options in the theory. So for strong consistency, users won't be able to get the updated data unless the data has been updated everywhere. So here we can see in West US writes, reads, East US reads, everywhere the data will be consistent. Users will be getting only the same updated data, and it will not get the data unless it's updated everywhere. So in bounded staleness period, we can set the staleness period for which the users won't be getting data. So if we're giving 2 hours as a staleness period, once the data has been updated, it will be everywhere in the world when someone is accessing, they'll get the updated data only after 2 hours the data has been updated. So it gives enough time for every server to have the replicated data. Then there is session consistency, consistent prefix, and eventual consistency. In eventual consistency, the people who are closest to the write location will get the data much faster than the read locations which are farther away from the write location. So that is what consistency is about. Then there are the backup and restore options. Here we can select the backup intervals and also the retention period for which the data is stored. So then there is these keys. So these keys are for when you are using some kind of language to query the database. So for example, if you're using Python or C#, you need these keys so that you can access the database. So that is how you create an Azure Cosmos database. So that ends the demo. Thank you.
Just a quick info, guys. Intellipaat provides Microsoft Azure certification training, mentored by industry experts, the course link of which is given in the description below.
Okay guys, we've come to the end of this session. I hope this session was helpful and informative for you. If you have any queries, leave a comment down below.
Thanks for watching.